Hello, everyone. My name is Mr. Laughlin, and I am your new math teacher. I'm very sad I can't be there yet, but until I am, I will be with you over the internet and through videos, and perhaps even live sometimes. But hopefully, I will be there very soon, and we won't have to do it over the internet anymore. Today, I want to introduce you to myself just a little bit. I will tell you a few things about myself, just so you can get to know me a little bit. And then we will review some things, we'll do some revision, we'll talk about the divisibility rules, which I've heard you may have heard before. We'll practice that a little bit. We'll talk about factors, and eventually we will get to the highest common factor. That's our goal, is to figure out how to find the highest common factor between two numbers today. After we get through all of that, and this video is nearing its end, then I will tell you a bit about the practice problems you're going to do at the end of class. So, me. This is me. I am 32. My name's Mr. Laughlin. I have a wonderful family, a wife, and a kiddo. My kid's 4. His name is Crosby. He loves dinosaurs. I love to play guitar and rock climb. And I love science and math. And I've been teaching. This is my 5th year teaching. And I'm excited to be your math teacher this year. So, let's talk math. Divisibility. This is when one number can be divided by another number, and the result is a whole number. So if you think back to learning how to divide things, sometimes when you divide things, you get a remainder, right? Like you divide 9 by 2, but 2 doesn't go into 9 evenly, so you have a little bit left over. Right? That's a remainder. If that happens, it is not divisible, right? But let's say you divide 8 by 2. 2 can go into 8 4 times, right? And that goes in there 4 times perfectly. There's nothing left over. 2 times 4 is 8. 8 divided by 2 is 4. There's no remainder. That would mean it is divisible, right? So if you're doing long division, like in these cases, we've got two numbers, 39 and 37, and we're dividing both of them by 3. If 3 can go in an amount of times with no remainder, it is divisible. So this first one, 39 divided by 3. 3 goes into 39 13 times, right? It goes into the 3 once and the 9 3 times, 13 times. It is divisible because there's no remainder at the end. However, 37. 3 goes into 37 12 times, but there's 1 left over. There's a remainder. So it's not a whole number that you get at the end. So it is not divisible. 37 is not divisible by 3, right? So 39 is divisible by 3, and 37 is not. 3 goes into 39 13 times exactly. 3 goes into 37 12 times, but has a little bit left over, so it's not divisible. So this is what we mean when we're talking about divisibility. Hopefully you've seen this before. You kind of know what this is. There are rules for the digits. Some of them are simpler than others. We will not talk about every single rule, but we'll hit a lot of the main ones. But the easiest one is 1. All numbers are divisible by 1, right? Anything divided by 1 is itself. So 1 divided by 1 is 1. Think of anything. Think of the biggest number you can, right? 1 million. 1 million divided by 1 is 1 million, right? Everything can be divided by 1. So you always get 1 as a factor when you're dividing. When we move on to talking about 2, this rule is also pretty simple, right? We've got some numbers up there. 3,246, 6,782, 4,070. Do you think these numbers are divisible by 2? You can probably tell just by looking at them. But if you don't know, that's okay. This is a simple rule. If a number is even, it will always divide by 2, all right? And how do we know if a number is even? There's a quick way to know. Look at the last digit. If it's a 0, a 2, a 4, a 6, or an 8, then the number is divisible by 2, right? And we're excluding the number 0, right? So anything that ends in a 0 that's not 0 is divisible by 2. 10 is divisible by 2. 10 divided by 2 is 5, right? 50 is divisible by 2. 50 divided by 2 is 25. Anything that ends in an even number, you can divide by 2. That's simple enough, hopefully. Right, and so there you go. Look at the last digit. There's a 6, a 2, and a 0, so all 3 of those numbers would be divisible by 2. Divided by 3. This one is a little bit more complicated, but if you sum all of the digits in a number, and that number is divisible by 3, then your big number you started with is also divisible by 3. So to put it simply, let's look at this number. 153, right? This number right here. If we add these up and they equal something that can be divided by 3 with no remainder, then this number is divisible by 3. So 1 plus 5 plus 3. We sum them, we add them up. They equal 9. 9 divided by 3 is 3, right? With no remainder. So 153 is divisible by 3. So this is how you can get even really big numbers and see if they're divisible by 3. You just sum up each of the digits, and if it is a number that is divisible by 3, you are good to go. We could think of something else like 17, right? 1 plus 7 is 8. 3 does not go into 8 and give you a whole number. You get a remainder, so that would not be divisible by 3. Dividing by 4. So if you see a big number and you want to know if you can divide by 4, you look at the last digits of the number, and if those last 2 digits are divisible by 4, then the whole thing is divisible by 4, no matter how big it is. So let's look at this gigantic number, 1,543,612. Humongous. The last 2 digits, though, they're 12, right? 12, can that be divided by 4? Yes, it can. 12 is divisible by 4, right? 12 divided by 4 is 3. And this means that our big number, 1,543,612, is also divisible by 4. You can do this with anything, no matter how big or small. Another thing to note, if a number ends in 0, 0, it is also divisible by 4. The best example of this is 100, all right? 100 divided by 4 is 25. You can do this with anything. 200 divided by 4 is 50. So anything that ends with 0, 0 in its last slots, its last digits, is going to be divisible by 4. Dividing by 5. So 5 is simple. Look at the last number. If it ends in 5 or it ends in 0, it is divisible by 5. So if we look at these numbers, 6,536, that last digit is a 6, which is not a 5 or a 0. That is not divisible by 5. 6,240, that last digit is a 0, right? That follows our rule, 0. So this is divisible by 5. 255, that last digit is a 5. So this is also divisible by 5. There you go. All right, so this one's easy. Just pay attention to the very last digit. Is it a 0? Is it a 5? If yes, then it is divisible by 5. Dividing by 6. This one's kind of interesting. This one has a bit of a process to it. So if you want to test if a number is divisible by 6, you must see if it can be divided by 2 and also be divided by 3. So you need to do basically both tests, the dividing by 2 test and the dividing by 3 test. If it passes both tests, then it is divisible by 6. So let's look at this big number, 6,924, right? So let's run our test for 2. Our test for dividing by 2 is the last digit even? So we know 4 is an even number, so yes, it can be divided by 2. Our next test for dividing by 3. Add up all of these digits, and then see if that is divisible by 3. So let's do that. 6 plus 9 plus 2 plus 4 is 21. Is 21 divisible by 3? Yes, it is. So this big giant number we know is divisible by 6 because it passed both of our tests. This one, there's a bit of a process. You have to do both these, make sure it can be divided by both 2 and 3, and then you know it is divisible by 6, right? We're going to skip a few numbers. We're going to go to 9. 9 is not too hard. We're adding up all the digits to see if the total is divisible by 9. If so, the whole number is divisible by 9. So this is very similar to the dividing by 3 rule, but now we're using the digit 9. So we're adding everything up. 225, 2 plus 2 plus 5 equals 9. 9 can be divided by 9, right? You get 1. So it is divisible. Let's look at this number. 5 plus 6 plus 2 equals 13. 13 is not divisible by 9. So this number is divisible by 9. This number is not divisible by 9. And 10, also a simple rule. If it has a 0 at the end, it will always be divisible by 10, no matter how big the number. 10, 20, 30, 40, right? All divisible by 10. 1 million divisible by 10. 153,469,780. That is divisible by 10 because it ends in a 0, right? Oh, whoops. That's going in the wrong order, right? But you get the idea. To test if a number is divisible by 10, simply look at the last digit. If it's a 0, you are good. If it is not a 0, it is not divisible by 10. So what about this? 652,430. Is this divisible by 10? Yes, it is. Ends in a 0. So let's